Hello everyone, welcome to my new lesson video, and this time I will be discussing the concept of heat, specific and latent heat, as well as phase change or the phase transition of a substance. I am your teacher, Mr. Mark Anthony B. Laroya. So let us now begin by discussing the concept of heat. What is heat? Heat is energy that is transferred from one object to another because of a temperature difference. The energy becomes part of the total energy of the molecules of the object or system once the heat is transferred, and it is now called as internal energy. The change in temperature is due to a change in the thermal energy of the system because of a transfer of energy between the system and the system's environment. When heat is transferred between two objects, either by conduction, convection, or radiation, they are said to be in thermal contact. Let's say, when heat is transferred or absorbed by the system, heat is said to be positive. But once heat is removed from the system or heat is released, Q is negative. Take note that the process of heat transfer is always from warmer to cooler, or warmer objects always heat cooler objects, but the reverse never occurs. Let us now talk about the change in temperature of an object or substance. In order to change the temperature of a substance, an amount of heat is required. This amount of heat, or Q, is proportional to the mass of the substance as well as to the change in the temperature of the substance. This temperature change also depends on the nature of the substance. In order to solve for the amount of heat absorbed by the substance, we have the formula Q is equal to mc delta T, where Q is the amount of heat, M is for the mass of the substance, C is the specific heat, and delta T is the change in temperature. Delta T is also equal to final temperature minus the initial temperature. But what is specific heat? Specific heat is the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Since specific heat is a factor to solve for the amount of heat absorbed by the substance needed to raise its temperature, it is very important that we know the specific heat of the substance. So this is the list of specific heats of various substances. In able to understand clearer the concept of specific heat as well as the change in temperature of a substance, let us now solve a sample problem. Determine the amount of energy needed to increase the temperature of 100 grams of wood by 3 degrees. To solve this problem, let us first identify the given. Our material is wood. The change in temperature or the delta T is 3 degrees Celsius, and the mass is 100 grams, or that is equivalent to 0.1 kilograms. To solve for this, all we have to do is to simply use the formula of Q, that is, Q equals mc delta T. So all we have to do is to substitute the values of m and delta T to our formula, and the C of our material, which is wood, has an specific gravity of 1680 joules per kilogram degree Celsius. So Q is equal to 0.1 kilogram times 1680 joules per kilogram degree Celsius times 3 degrees Celsius. So the units of kilograms and degrees Celsius will be cancelled, and we will be left with the unit of J or joules. So, computing this, we will arrive at the answer Q, or the amount of heat, is equal to 504 joules. That is the amount of energy or heat needed for a 100 gram of wood to increase its temperature by 3 degrees Celsius. Another problem involving specific heat and change in temperature of a substance will be this one. What was the mass of water that absorbed 6,000 joules of heat to increase its temperature from 18 to 23 degrees Celsius? The specific heat of water at this temperature is 4,186 joules per kilogram degree Celsius. So first, let us identify the given. The material is water at 18 degrees Celsius initially. The amount of heat that water absorbed is equal to 6,000 joules, and the change in temperature is from 18 degrees Celsius up to 23 degrees Celsius. To solve for the mass of water, let us begin from the formula Q equals mc delta T, where delta T is also the same as change in temperature, or that is final temperature minus the initial temperature. Using this formula, to solve for m, we divide both sides by C times the quantity Tf minus Ti. So we will arrive at the formula mass of the substance, or mass of water, will be equal to Q all over C times the quantity Tf minus Ti. So we can now substitute all of these values to our formula for mass, and this will become 6,000 joules all over the specific heat of water, 4,186 joules per kilogram degree Celsius, times the difference in temperature 23 minus 18 degrees Celsius. As we can see here, the units of joules and degrees Celsius will be cancelled, and we will be having now an answer. Mass of water is equal to 0.287 kilograms, or that is also equal to 287 grams. After discussing the change in temperature of a substance due to heat transfer, let us now talk about the phase change of a substance. What is phase change? Phase change is a transition from one phase to another, or also known as phase transition. This diagram shows the phase change that a substance can undergo. The molecules of a solid are held together by attractive forces or bonds. If enough heat is absorbed or added to the substance, it provides sufficient energy to break the intermolecular bonds, and the solid undergoes a phase change and becomes a liquid. The temperature at which this occurs is called the melting point. On the other hand, if enough heat is taken out of a liquid, it becomes a solid, and the temperature at which this happens is called the freezing point. The melting and freezing temperatures of a substance are the same. When sufficient heat is added to a liquid, it changes to the gaseous or vapor phase. The temperature at which this occurs is called the boiling point. The temperature at which a gas condenses and becomes a liquid is the condensation point. The boiling point of a substance occurs at the same temperature as its condensation point. Some solids, such as dry ice or solid carbon dioxide, air fresheners as well as mothballs, change directly from solid to the gaseous phase. This process is called sublimation. On the other hand, a phase change from gas to a solid is called deposition. In general, when heat energy is transferred to a substance, its temperature increases. However, when added or removed, heat causes only a phase change. The temperature of the substance does not change. When we talk about latent heat is the heat involved in a phase change of a substance. There are two types of latent heat. The first one is the latent heat of fusion, or LF. It is the heat involved in the phase change of a solid turning into liquid. And the other one is the latent heat of vaporization, or LV, that is the heat involved in the phase change of a liquid turning into gas. The formula to compute for the amount of heat involved that causes phase change, Q is equal to mL, or mass of the substance times the latent heat involved, either latent heat of fusion for turning solid into liquid or latent heat of vaporization LV turning liquid into gas. Here is a list of latent heats of different substances. For example, for water, the latent heat of fusion for water is 3.33 joules per kilogram. This latent heat of fusion will only involve in the computation once water starts to turn from solid to liquid at the temperature of 0 degrees Celsius or at melting point. Same goes for its latent heat of vaporization, which is equal to 22.6 joules per kilogram. This value will only be involved once water reaches the temperature of 100 degrees Celsius or its boiling point, wherein it starts to turn from liquid to gas. To better understand the concept of latent heat, let us solve a problem. How much heat is needed to liquefy 200 grams of tungsten? Before we solve this, we must first consider that the tungsten should reach a temperature of 3410 degrees Celsius. It is the melting point of the tungsten before we add heat for it to be liquefied. To solve for the heat needed to liquefy 200 grams of tungsten, we now use the formula Q is equal to mass times the latent heat of fusion for tungsten. Latent heat of fusion because we're going to change the phase of tungsten from solid to liquid. The latent heat of fusion for tungsten is equal to 1.8 joules per kilogram. So all we have to do is to simply substitute the values of the mass and the latent heat of fusion of tungsten to our formula. But first, remember that 200 grams is the same as 0.2 kilograms. And so we will be having Q is equal to 0.2 kilograms times 1.8 joules per kilogram. Using this formula, we can see that the unit of kilograms will be cancelled. And then we will now have the answer 0.36 joules, meaning once the tungsten reaches the temperature of 3410 degrees Celsius, its melting point, we now have to add an amount of heat equal to 0.36 joules to liquefy the tungsten. I will now be discussing the phase changes of water. or what the water is undergoing as it absorbs heat. So let us consider that the pressure is 1 atmosphere and we will begin at a temperature of negative 5 degrees Celsius. So at this condition, we all know that water is solid or in the form of ice. So starting from negative 5 degrees Celsius, it increases as it absorbs heat. The temperature rises up to 0 degrees Celsius. This is now the stage 1, wherein at this stage, there is change in temperature or there is a value for delta T, meaning from negative 5 it moves to 0 degrees Celsius, but the water remains solid, no phase change. To solve for the amount of heat that is involved at this stage, Q will be equal to mass of the substance or of the water times the specific heat of water at this condition wherein it is still in ice form times the change in temperature. Then, starting now from 0 degrees Celsius for a moment, it will remain at 0 degrees Celsius for the meantime. This is now stage 2, wherein the value of delta T is equal to 0, meaning there is no change in temperature. However, at this stage, there is a phase change. At 0 degrees Celsius, we know that this is the melting point of water. So therefore, water now starts to change its phase from solid to liquid. And to solve for the amount of heat involved, Q now will be equal to mass of water times its latent heat of fusion. Latent heat of fusion because water now starts to convert or starts to turn from solid to liquid. Now, as we continue to add heat to the water, and now water is at liquid phase, it will now increase its temperature going up to 100 degrees Celsius. This is now the stage 3, wherein obviously there is a change in temperature. We can get the value of delta T, but at this stage, water is still in liquid phase. No phase change will happen. The amount of heat needed for this can be computed using Q equals mass times the specific heat of water at this stage wherein it is in liquid form, which is different from the specific heat of water at stage 1, mass times the specific heat of water times delta T. And then, after some time, once it reaches 100 degrees Celsius, it starts to boil. It will maintain its temperature at 100 degrees Celsius, and this is now the stage 4, wherein there is no change in temperature, but there is a change in phase. The Q now here will be equal to mass times the latent heat of vaporization. Latent heat of vaporization because water now starts to turn from liquid into gas. And then lastly, as we again continue to add heat or as we continue to increase the temperature of water or we add heat to water, temperature now will rise beyond 100 degrees Celsius, let's say 105 degrees Celsius or 110 above 100 degrees Celsius. This is now stage 5, wherein there is a change in temperature but no more phase change. And to solve for the amount of heat at this stage, Q is equal to mass times the specific heat of steam. Take note, it's the specific heat involved here is already the specific heat of a steam times the change in temperature. This is the processes that water undergoes once it absorbs heat from its solid state to gas form or gas phase. But if once water releases or heat is removed from the water, the process is reversed. From gas, it will turn into liquid, and from liquid, it will turn eventually into solid. Now, for each of this stage, there are values of Q. You have Q1, or the amount of heat for stage 1, as well as for stage 2, 3, 4, and 5. To solve for the total amount of heat involved to change water from solid or ice at negative 5 degrees Celsius up to a certain temperature beyond 100 degrees to turn it into steam, or the Q total is equal to Q1 plus Q2 plus Q3 plus Q4 plus Q5. Or simply, you add all the Q's that we get from different stages. Let us now solve a problem involving change in temperature and change phase of water. Determine the amount of heat required to change 0.5 kilogram of water at 27 degrees Celsius to steam at 110 degrees Celsius. So take note that water will first heat will be transferred to water to change its temperature from 27 degrees Celsius going up to 100 degrees Celsius. And once it reaches 100 degrees Celsius, water now will start to boil. And that during that level or stage, water will start to turn from liquid to gas. And then once it turns into gas, it will now start to increase its temperature again from 100 going up to 110 degrees Celsius. So, at stage 1, liquid water warming from 27 degrees Celsius up to 100 degrees Celsius. No phase change. So, we can use the formula Q is equal to mc delta T, or the specific heat of water at its liquid phase. So we have 0.5 kilograms times the specific heat of water at this phase of water, liquid phase, 4,186 joules per kilogram degree Celsius, times the change of temperature from the final temperature here will be 100 degrees Celsius minus 27 degrees Celsius. So we will now have Q1, or the amount of heat involved at this stage, is equal to 152,789 joules. That is the amount of heat that increases the temperature of water from 27 degrees Celsius up to 100 degrees Celsius. At stage 2, at 100 degrees Celsius, the water will boil and starts to transform from liquid into gas without temperature change. So that means our formula now for Q2 will be mass times the latent heat of vaporization. It's because water will start to transform from liquid to gas. So that is 0.5 kilograms times its latent heat of vaporization, which is 22.6 times 10 raised to 5 joules per kilogram. So this will give us 1,113,000 joules. That is the amount of heat that changed the phase of liquid water to gas at 100 degrees Celsius. And finally, this will be our last stage, stage 3. Starting from 100 degrees Celsius, the steam will now continue to increase its temperature up to 110 degrees Celsius, and it will remain in gaseous phase. So Q3 will be mass times the specific heat of steam times the change in temperature. So that is 0.5 kilograms times the specific heat of steam, which is 2010 joules per kilogram degree Celsius, times the change in temperature 110 minus 100 degrees Celsius. So we will be having Q3 is equal to 10,050 joules. That is the amount of heat that increased the temperature of the steam from 100 degrees Celsius up to 110 degrees Celsius. And so, to determine the amount of heat that the water absorbed from 27 degrees to 110 degrees Celsius, we simply add the amount of heat that we got from each stage. So Q total will be equal to Q1 plus Q2 plus Q3, or that is simply equivalent to a total of 1,275,839 joules. That is the total amount of heat absorbed by the water from 27 degrees Celsius, turning it from liquid to gaseous phase or steam at 110 degrees Celsius.